So here the question says a survey was conducted to find out at what time and the number of times 100 people ate a meal the day before. The following table shows the results of the survey. So these are the time slots in which these people ate. The table gives the time slot in which people started eating. No one ate a meal before 00 to 6. Any time slot such as 6 to 8 includes time after 6 to 8. It was found that each person ate at least once and at most 4 times on the day of the survey. It is also known that all people ate their first meal in this time, and the second meal in this time, third meal in this time, and the fourth meal in this time. That's how it is given to us. And straight away, then we have questions. So, what I have done, I have written these time limits in the table itself, and according to that, I will be answering the questions. So straight away, I'll move on to the questions. I'll show you how did I write them. What is the minimum possible number of people who ate the second time? So here is the table that is given to us. He said that people can eat for the first time from 6 to 14. So therefore, I've written first up to 14. People eating for the second time can eat from 10 to 16. So from 10 to 16, I have written second. People eating for the third time can eat from 14 to 22. So therefore, I have written third, and third over here. Similarly, people eating for the fourth time can eat from 20 to 00. So that I have written at the end. So basically, that in one time slot, people can eat for what time? That's what I have written in this table. Now, what is the question asking us? Question is saying, what is the minimum possible number of people who ate the second time? I have to minimize the people eating the second time. Then, first of all, these 14 plus 32, that is, these 46 people must have eaten for the first time only, because in these time slots, people can eat for the first time only. That's it. From 10 to 12, 42 people ate for the first or the second time. So let us assume these 42 people also ate for the first time only. So till now we have 88 people and they all have eaten for the first time. We have 88 people all ate for the first time. Now, can I take all of these 55 people also assuming that they all ate for the first time? The answer is no, I cannot do that. What is the reason for that? The reason is I have only 100 people. So if I have only 100 people, how can more than 12 more people can eat for the more than first time? That means from these 55, let us say 12 people ate for the first time. So now I have 100 people eating for the first time, and 55 minus 12. From here, 43 people ate for the second time. 43 people ate for the second time. Now, what can I do? I want to minimize the people who ate for the second time. 100 people ate for the first time. 43 of them ate for the second time. What if I assume that all these people ate for the third time? These people also ate for the third time. These people also ate for the third time. They are fourth. They are fourth. In that case, I will have only 43 people eating for the second time. But does that satisfy? And if that does not satisfy, why not? Let's talk about that. 34 plus 25, these 59 people surely ate for the third time. Now, just the point is, if 43 people have eaten for the second time, how can 59 people eat for the third time? Because a person who is eating for the third time, he must have eaten for the second time as well. You can't eat straight away for the third time after first. Therefore, we can say the number of people eating for the second time must be greater than or equal to the number of people eating for the third time. Of course, that should be greater than equal to the number of people eating for the fourth time. And of course, this should be less than equal to the number of people eating for the first time. I'm sure you got my point. Because if, let us say 20 people ate for the third time, how can 30 people eat for the fourth time? Because a person eating fourth must have eaten third. So everyone eating third time, right? He might or might not eat fourth, but everyone eating fourth time must have eaten third time. That's the logic that I'm using over here. So I am getting 59 people eating for the third time, which is more than 53, 43. That's not possible. Plus, I'm also talking about these 59, and I'm assuming they all also would be third time. So to minimize the people eating for the second time, let us assume From these people, A of them ate for the second time. So automatically I can say 59 minus A ate for the third time. I hope you got my point. Let us assume A people here ate for the second time and 59 minus A eat for the third time. So number of people eating for the second time according to this is 43 plus A, and number of people eating for the third time is 59 minus A plus 59, that is 118 minus A, and I want that 43 plus A should be greater than or equal to 118 minus A. This gives me 2A should be greater than equal to 118 minus 43. That means A should be greater than equal to 118 minus 43 is 57 plus 18, that is 75 divided by 2. So A should be greater than equal to 37.5. So can I say A will be minimum 38? And keeping A as minimum, I would be able to minimize the people eating for the second time. So number of people eating for the second time minimum is 43 plus 38, that is 81. So 81 is the correct answer for us. Now you might have this question, sir, what about these people? Of course, people eating for the fourth time, I have taken only these and they all are becoming 75. So 81 this is. According to A as 38, this comes out to be 80. This is 75. So yes, it satisfies that 81 is greater than equal to 80 and 80 is greater than equal to 75. So 81 is the minimum number of people who can eat for the second time. That's the answer for this first question. So this question says the number of people who ate 4 times is minimum possible. What is the number of people who ate the third time between 20 and 22? So once again, I have to keep all those things in mind which I discussed in the previous question. I want to minimize the people who ate for 4 times. I want to minimize the people who ate for 4 times. What is the number of people who ate the third time? So what is the number of people who ate for the third time? So I can assume to minimize the people eating for the fourth time, can't I just assume that these people, they necessarily ate for the fourth time? You can't change it. But can I just assume that all the people here ate for the third time? All the people here ate for the third time. All the people here ate for the third time. Can I do that? Let's try. If I give it a try, 34 plus 25 is 59. 59 plus 48. 59 plus 48 becomes 107. 59 plus 48 becomes 107. That means I cannot have 107 people eating for the third time. So at least 7 would be eating fourth time over here. At least 7, right? I'm not saying exactly 7, but at least 7 would be eating fourth time over here. In that case, what happens? Let's talk about that. 41 people would be eating third time over here, 25 would be eating third time over here, 34 would be here. That makes the total as 100. So by this logic, till now I'm saying people who ate for the third time are 100. People who ate for the fourth time are 27 plus 7, that is 34. But if 100 people ate for the third time, then 100 people must have eaten for the first time and 100 must have eaten for the second time. Of course, they cannot be 100. You can't have less than 100 as well. They can't be more than 100 as well. So the only possibility is they have to be 100. How can I make them 100? 14 plus 32, which is equal to 46. 46 plus 42. 46 plus 42 is 88. So here 12 people eat for the first time. I will have 100 people eating first time. The remaining 43 people would eat for the second time. Let us say all of these 59 people eat for the second time. 43 plus 59 is making it 102. So if I take 43 people here eating for the second time and 59 here eating for the second time, that is making the total as 102. But I can't have a total of more than 100. That means people eating for the third time, there must be at least 2 here as well. There must be at least 2 here as well, so that I have 57 people eating for the second time. 43 plus 57, that is 100. This is 14 plus 32 plus 42 plus 12 as 100. And out of these 59, when 57 people eat for the second time, these 2 people will eat for the third time. These 34 will eat for the third time. These 25 will eat for the third time. So now I have to further decrease it by 2 to make it 100. So यहाँ 39 would be there, and that makes this as 9. So the question is, what is the number of people who ate the third time between 20 and 22? My answer is 39. So for question number 12, that is the right answer for us. Here is question 13. If the minimum possible number of people ate the second time, what is the number of people who ate the third time between 14 and 16? Minimum possible number of people ate the second time. We did it in the very first question, if you guys remember. So we got these 88 eating at the first time. From here, 12 people eating for the first time, 43 people eating for the second time, if you guys remember this. And out of these 59, I said that 38 people, which we took as A, 38 people are eating for the second time. So 59 minus 38, 21 people ate for the third time. This all was discussed in the first question of this set, where we discussed this, if you guys remember. It was 43 plus A should be greater than equal to 118 minus A, something like this we got, from which we got A as 38. So 21 people in this time slot would be eating for the third time. That's what the question is asking us. So answer is option A for this. Now question number 14 says, if no person ate exactly 2 times, what is the maximum number of people who ate the fourth time between 20 and 22? Okay. No person ate exactly 2 times. That means if a person ate for 1 time, either he did not eat for the second time, or he also ate for the third time. If anyone is eating for the second time, he must be eating for the third time as well. That's what the question is saying. So what is the maximum number of people who ate the fourth time between 20 and 22? Maximum number of people who ate for the fourth time between 20 and 22. So what can be maximum for that? So I want here maximum number of people eating for the fourth time. So that means let us try that all 48 eat here for the fourth time. Let's try that. So these 25 people ate third time. These 34 people ate third time. That makes it 59. What if we do just like the previous question? In the previous question, I said 38 people are eating for the second time. 43 people are eating for the second time. 21 people are eating for the third time here. And 100 people, that is 12 from here, and all of these 100 people are eating for the first time. 81 people are eating for the second time. 21 plus 34 plus 25, that is 80 people are eating for the third time. But if I have 81 here and 80 here, in this case, I am having one person now. I am having one person who actually has not eaten the third time, but he has eaten for the second time. So that one person must eat for the third time. So I can take that one person over here. The remaining 47 people in this time slot can eat the fourth time. So therefore, the right answer for this question will be 47 for us. And this question says, if no person ate exactly 1 time, what is the minimum number of people who ate the third time between 20 and 22? He says no person ate exactly 1 time. That means every person who ate first, he also ate second. What is the minimum number of people who ate the third time between 20 and 22? I want to minimize the people eating for the third time here. I want to minimize the people eating for the third time here. Let's try that. So once again, let us assume that all 100 people have eaten for the first time. All 100 people have eaten for the first time. That means 14 plus 32 plus 42 plus 12 from these. That makes it 100. So people eating for the second time should also be 100, right? People eating for the second time, they should also be 100. So I would be left with 43 people from here. And let us say all of these 59 eat for the second time. But 59 plus 43 will make it 102. So I can take 57 people eating for the second time. So 43 plus 57 people ate for the second time, that is 100. 100 people ate for the first time. My condition is satisfied that no person ate exactly once. because these 100 people now, they all have eaten for the second time as well. But now I have 2 people here eating for the third time, 34 people over here eating for the third time, 25 people over here eating for the third time. 2 plus 34 plus 25, that makes it 61. 61 people eating for the third time. So can't I have 0 people here eating for the third time? Let's try that. I cannot. The reason? 48 plus 27. How can 75 people eat for the fourth time when only 61 have eaten for the third time? As we have discussed before as well, people eating for the third time should be greater than equal to the people eating for the fourth time. So therefore, out of these 48 people, some will have to eat for the second time, third time as well. Once again, let us say A people eat for the second time. So 48 minus A people, sorry, third time, 48 minus A eat for the fourth time. So this 61 is the number of people eating for the third time before plus A more. This should be greater than equal to the number of people eating for the fourth time, which is 48 minus A plus 27. So 61 plus A is greater than equal to 75 minus A. So 2A is greater than equal to 14. A is greater than equal to 7. That means minimum 7 people out of these 48. That means minimum 7 people in this time slot must be eating for the third time. Therefore, my answer for this question is option B, that is equal to 7.